Hello students, welcome to Notebook Videos. Before starting with today's discussion, let us keep maths and its problems aside and have a short storytelling session. Let me tell you a story about our own country. In the early 1990s, India was in serious economic trouble. Rising oil prices from the Gulf War and the fall of the Soviet Union were among the many reasons behind this. As a result, the government introduced massive economic reforms in 1991 that opened up the Indian economy to foreign investment. And the results were spectacular. With its economy growing steadily, rapid industrialization started. By the turn of the 21st century, India had progressed towards a free market economy along with increased life expectancy, literacy, and food security. The four industrial centers of Delhi, Mumbai, Chennai and Kolkata were quickly becoming hubs of economic and industrial growth. The problem was that their associated infrastructure could not grow at the same pace. A major issue among many was the poor road connectivity between them. These cities were connected by a series of national highways of different sizes, conditions and ages. The non-uniform road connectivity remained a major problem in the transport of passengers as well as goods and raw materials between the four cities throughout the 90s and the turn of the century. To curb this increasing bottlenecking of road-based logistics, the Indian government proposed an ambitious project that involved connecting the cities through 4- and 6-laned highways and expressways, creating India's first superhighway network and the world's fifth largest, with a length of 5,846 kilometers. The project was officially completed in 2012 and cost well under its projected budget. Considered the first phase of the National Highways Development Project, this flagship network connects the four metropolitan hubs at four corners of India. When viewed on a map, the roads seem to be a massive four-pointed polygon. As a result, this project was aptly named the Golden Quadrilateral. Overall, the Golden Quadrilateral had massive effects on transport, urbanization, rural development, and the industrialization of modern India. Wherever this network passed through quickly became areas of economic and industrial growth. Now that logistics were simpler. True to its name, this quadrilateral of highways was actually golden to the growth of India. A quadrilateral, as we have learned before, is the name for any four-sided polygon. Just like the significance of the project in the industrialization of India, the quadrilateral shape also holds a special significance in maths. Over the next few videos, we will dive into the depths of the four-sided polygon and learn about its features and properties. We will also talk about polygons in general and their geometric properties. Finally, we will analyze some of its very special forms: the kite, the trapezium, and the parallelogram. We will look into the details of these shapes, their properties, their angles, sides, and also solve some problems on them. So be prepared for a series of videos detailing polygons, not quite golden quadrilaterals, and its various offshoots. Team Notebook welcomes you to the world of quadrilaterals. You remember Dimitri, our friendly magician? He is back, teaching the boy all about 2D shapes.
So, I hope that you have been keeping up your maths practice. Today we will start learning something new. Tell me, do you know what this is?
It's a straight piece of wire.
Yes, you are right. But do you know what is this geometric figure called? It is a line segment. On the other hand, if we bend this wire, we end up with a curved line. If we keep on bending the wire until its ends meet, what we have is called a closed curve.
Wow.
Instead of curves, we can also bend the wire to make sharp angles. This is called a polygon.
So, you are saying that any figure made of straight lines only is a polygon?
Not any figure, it must be a closed figure. A polygon is a closed figure made of straight line segments of same or different lengths.
Polygons are closed curves, made up of only line segments. They are named based on the number of sides or vertices.
Look at this shape. It is a 5-sided polygon. As a result, it is called a pentagon. And this 7-sided shape is called a heptagon.
This handy chart shows how polygons are named based on the number of sides.
Now, polygons have some unique parts. You know about the sides and vertices. But do you know what these lines are?
They seem to diagonally intersect the vertices.
Exactly. They diagonally intersect the vertices and are therefore called diagonals.
A diagonal is a line segment that joins the non-consecutive vertices of a polygon.
Now, you know about the interior and exterior of any closed figure, right? Basically, it is just some point or portion that lies completely inside or completely outside our figure.
What is so special about what's inside and what's outside?
Good question, good question. You see, in these lessons, we are primarily concerned about angles. And like any other points, we also have exterior and interior angles.
So, exterior angles are outside the polygon while interior angles are inside.
Precisely. Always remember this little tip. You see, interior angles are very important while classifying a polygon.
There are two ways of classifying polygons. The first involves the interior angles and classifies a polygon as concave or convex.
A concave polygon has at least one interior angle that is greater than 180 degrees. It looks a little like this.
Looks like a man shouting.
Ha 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 ha, you are right, it does. A convex polygon, on the other hand, has no mouth. All of its angles are less than 180 degrees.
Okay, so convex polygons have all angles less than 180 degrees, making them look roundish, while concave polygons have at least one angle greater than 180 degree, making them look bent in.
Perfect! The other way of classifying polygons is based on the length of each side.
A polygon that has all sides of identical length is called a regular polygon, while a polygon with different sized sides is called an irregular polygon.
So, regular polygons always have identical sides. Can you name two regular polygons that you already know about?
A square. I read that all sides of a square are equal.
Absolutely. And what about the other one?
What about a triangle?
Not just any triangle, but an equilateral triangle is a regular polygon.
Here are some examples of regular and irregular polygons. Now, there are two important properties of polygons. The first is the angle sum property. Basically, this property shows that any polygon can be broken into a group of triangles. As a result, the sum of the interior angles of any polygon can be expressed as a product of 180 degrees, since that is the sum of the interior angles of a triangle. Mathematically, it is seen that the number of triangles possible is always 2 less than the number of sides. That is, a quadrilateral will have 4 minus 2, that is 2 triangles, while a heptagon will have 7 minus 2, that is 5 triangles. The sum of their interior angles will accordingly be 180 multiplied by the number of triangles.
So, remember, the sum of interior angles of a polygon is always n minus 2 into 180 degrees.
For exterior angles, however, this is a different story.
Abracadabra! Start at the top vertex facing me. Now walk along the sides until you again reach that point.
Okay.
You see, at the end of the walk, you are once again facing me in the same direction. This means that the small turns you made throughout the path added up to a full rotation. What angle did you cover?
Well, if I complete 90 degrees anti-clockwise, I know that I will face my left side. For 180 degrees, I will face my exact opposite direction.
Yes, but how can you come back to face the same direction?
I have turned opposite to my original direction and then again opposite to that new direction. So I must have covered 180 degrees twice. So I went through 360 degrees.
Bravo, that is correct. For any convex polygon, the exterior angles will always add up to 360 degrees. Furthermore, if it is also a regular polygon, all the exterior angles will be equal, allowing you to easily calculate the number of sides from the angle if you are faced with such a question.
So with that, we reached the end of our first video in this new series. We learned about the basics of polygons, their types, as well as the angle properties. We will see you soon with more videos where we will start to discuss a specific type of polygon, the quadrilateral. Until then, goodbye from Team Notebook.